All right, today we're diving into a really fascinating challenge that isn't coming from outside the world of physics, but from deep within it. It's a provocative call to completely rethink how we describe the fundamental building blocks of our reality.
And it all boils down to this one huge question. When scientists are writing down all these complex equations for a particle, are they actually capturing the thing itself, or are they just describing the shadow it casts? Let's get into what that really means. So to really wrap our heads around this challenge, first we've got to look at where fundamental physics is right now. And the source we're digging into today suggests it's not just at a crossroads, it's more like it's lost in a maze.
And here's why. You see, modern physics isn't just one single picture. It's this vibrant, sometimes kind of chaotic mix of brilliant ideas. You've got string theory, loop quantum gravity, and a bunch of others, all competing to be the one true description of how everything works. The thing is, they're all incredibly powerful, but they're all incomplete.
And that right there gets us to the core problem. The source puts it very bluntly. For all these amazing ideas, not a single one gives us a complete working model. We have all these brilliant pieces, but the puzzle is nowhere near solved. So the argument goes that this has led to a sort of stagnation. The focus has shifted to making these tiny, incremental improvements to the theories we already have, instead of taking a big, bold step back and trying to build something totally new from the ground up. And this is where we get to the heart of the critique. The issue isn't just that the theories are incomplete. The argument is that the problem might be with the method itself, specifically, the way physicists are using mathematics. This really illustrates the point perfectly. The current approach is kind of like having separate instruction manuals for every feature on your phone. One for the camera, another for the battery, a third for the screen. What's being demanded here is a single blueprint of the phone itself, from which you can understand why the camera and the battery and the screen all work the way they do together. I mean, you can just feel the frustration in this quote, right? The author is basically calling out this practice of using these isolated mathematical tools to describe isolated properties, like a particle's spin, without ever explaining how that property connects to the particle as a whole. And calling it hiding, wow, that's some pretty strong language.
So let's be really clear here. The problem isn't with math itself. Math is the language of physics after all. The problem is using a patchwork of different mathematical sentences to describe what should be one single, unified thing. A list of ingredients is not the same thing as the cake.
Okay, so that brings us to the proposed solution. Because this isn't just a critique, it's a direct, constructive challenge laid down for the entire physics community.
And the challenge is laid out in these really concrete steps. First, don't just assume a particle exists. Build it from some kind of fundamental fabric. Second, you have to show how all of its properties, we're talking charge, spin, everything, naturally pop out of that single fabric. Then you've got to explain what that fabric even is. And finally, and this is the big one, build an analog. And that word, analog, that is the key to this whole thing. The demand isn't for a better, more complicated equation. It's for a model that we can actually get our heads around, something we can intuitively understand, not just calculate with. Think about the difference between a physical model of the solar system sitting on a desk versus the complex equations that govern planetary motion. That's what we're talking about. And this, right here, is really the philosophical heart of the argument. A formula is an incredibly powerful tool. It can predict what a particle will do with mind-blowing accuracy. But the formula isn't the particle. It just isn't, any more than the word water can quench your thirst. So what's the ultimate goal here? Where does a challenge like this lead? Well, it's about pushing physics beyond its current limits toward a much deeper and maybe more satisfying kind of understanding. What this is really is a search for a physics that doesn't just work, but that also makes sense on a deep human level. A physics that's not only powerful in its predictions, but is also beautiful and elegant in its explanations. It's a quest for intuition, not just calculation. And so we end up right back where we started, facing this fundamental question. If our best mathematical descriptions are just shadows flickering on a cave wall, what tools, what new ideas, what kind of thinking is it going to take for us to finally turn around and see the true shape of reality itself? That, right there, is the Fermion challenge.